All right, this is on complex rational expressions. A complex rational expression is also called a complex fraction, where we have numerators or denominators containing one or more rational expressions. So think about fractions inside fractions. So here are two examples of such expressions. So we have the first fraction is 1 over x inside this large fraction and another 1 over x. So these are considered a complex rational expression, this entire thing. Another one, we have a fraction and another fraction in the numerator. So one method for simplifying a complex fraction is to combine its numerator into a single expression and then combine its denominator into a single expression, and then perform the division by inverting the denominator and multiplying. So that means keep, change, flip. So let's go ahead and do the first method. So we're going to take this numerator and combine it into one fraction. So we need to change that 1 to x divided by x. If I reduce that back down, I get x divided by x is 1. The second fraction, I'm leaving it the same, 1 over x. What I just did is I made those two denominators the same because the LCD is x. Now I add those two fractions together, x plus 1 over x. So now my numerator is a single fraction. Now let's go to the denominator. We're going to combine that into one fraction. So I'm going to change that 1 to x over x, and the second fraction stays as 1 over x. Now my denominators are the same. That's your LCD of x. So I can combine them into one fraction, x minus 1 over x. So I have a single fraction dividing another single fraction. So now I'm going to keep, change, flip. So I'm going to keep the x plus 1 over x. So this is my keep. Then I'm going to change this division symbol to multiplication. And then I'm going to flip this purple fraction. You're inverting it. Now I'm going to go ahead and put parentheses. And before I multiply, I'm going to look and see if there's any common factors. There is one common factor. Those will both become 1. Now we have x plus 1 over x minus 1. We do have a domain restriction. We do not want x to be a 0 there or a 0 there. All right. Here's the second method, and this is the method that I prefer. The second method for simplifying is a complex rational expression to find the least common denominator of all of the rational expressions in the numerator and the denominator. Then what you do is you multiply each term in the numerator and denominator by the LCD. And what happens is lots of fun things are going to cancel out. So here's our example that we just did. The LCD is x. So you're going to multiply this fraction by x. You're going to multiply this fraction by x. So here's how it looks. Then what happens is this x and x cancel, that x and that cancel. So you're left with x plus 1 over x minus 1. Oh, I forgot one thing. There is one more domain restriction. We also don't want this final answer to have a 1 in its denominator, so there's a domain restriction of 1. All right, so I do prefer the second method. So I'm going to look for the LCD of all fractions. So I have the x, I have the 2, I have the x, and I have the 4. So the LCD of all 4 of those fractions is 4x. So I'm going to multiply everything by 4x. So here's how it'll look. I have 1 over x times 4x minus 3 over 2 times 4x all over 1 over x times 4x plus 3 over 4 times 4x. All right, now I'm going to look for the common factors. This x cancels, that x cancels. I can cancel by a factor of 2. I can cancel by a factor of 4. So what am I left with? I'm left with 1 times 4, which is 4, minus 3 times 2 times x, which is minus 6x, over 1 times 4, which is 4, and then 3 times x, which is 3x. Now we do have a domain restriction. What do we not want x to be? We do not want x to be 0, or we do not want this to be 0. So we have to set that equal to 0 and solve for x. So we don't want x to be negative 4/3. Here's example 3, simplifying this complex rational expression. I'm going to go ahead and put a 1 in the denominator here. So now we have our 3 fractions. We're looking for the LCD. So the first fraction, denominator, denominator, denominator. So the LCD of this denominator is x quantity x plus h. So you're going to multiply this fraction by x, x plus h. You're going to multiply this fraction by x, x plus h, and this fraction by x, x plus h. All right, now we're ready to start canceling any common factors. So the first fraction has a common factor of x plus h. The second fraction has a factor of x. And the third fraction doesn't have a common factor. So what are we left with? We're left with x times 1, which is x, minus 1 x plus h, divided by h, x, x plus h. Now we're going to simplify the numerator, so I'm going to distribute the negative 1 through. Now what happens is these x's become 0. And then we have a common factor of h. So our final answer is negative 1 over x, x plus h. And then we do not want x to be 0.